Hello! So finishing off Unit 15, it's all about using formulas to find area, volume, surface area, and something called lateral area. So what each of those are, let's start it with area. Area is the space occupied by a two-dimensional flat shape. So just picture a triangle drawn on a piece of paper. It's how much space is taken up inside of that triangle. And you're going to label your answer with units squared. Next one we're going to work with today is volume. Volume's that same idea. It's the amount of space occupied, but it's by a three-dimensional solid. So let's picture now maybe a pyramid. How much space is that three-dimensional pyramid taking up? And that's going to be measured in units cubed. Okay, surface area and lateral area are kind of confusing because we just talked about area being two-dimensional, but you can only find surface area and lateral area of three-dimensional objects. So picture a three-dimensional object. Let's just picture this one that I have drawn right here, a rectangular prism. Surface area is the total area of all of the surfaces. Now, if you look at the surfaces, meaning like the faces, like we talked about in the last video, you have a rectangle here, a square or a rectangle back here. You have another rectangle here. Those are all of your surfaces, and they go on. There's more and more. There's 6 total surfaces. Just so we have them all colored. You know, this isn't messy at all. It's really hard to show three-dimensional on a drawing. Okay? But there's 6 surfaces here, so the surface area would be if I were to take the area of all of the sides. So this right here is my first side. If I took the area of that, set it aside, whatever it may be. Then I take the area of this rectangle, set that aside, whatever it may be, and find the area of all 6 faces. I would then add all of the areas together, and that would get me my surface area. You know, because it is area, it's not measuring the space taken up on the inside of the three-dimensional shape like volume does. So it's not units cubed. You're still using area formulas, and you are still finding the overall area, but it's of several shapes that make up the three-dimensional solid. So it's going to stay units squared. All right, now lateral area is a type of surface area. Sometimes in the Apex quizzes, it'll be referred to as lateral surface area, but if it has that word lateral, it's the same concept as surface area, but it is not including the base or the top. Okay, so it's still taking the area of all of the faces, excluding the base and the top. So it would only be your side shapes. Now using that same idea, because lateral area is a type of surface area, again, just excluding the base and the top, it's also going to be units squared because it is in area. So the only units cubed we have is volume, and it's because we're finding the space on the inside of a three-dimensional object. I know surface area and lateral area are using three-dimensional shapes, but you're finding the area of the shapes that make up the three-dimensional object. So here's a better picture of what lateral area would look like because I had no idea how to draw it for you. I figured I'd just paste a picture for you. So the base is the one like on the ground. So look at the three-dimensional. These 4 objects right here are the same shape. They're just highlighting what would actually be used for lateral area. So notice the base and the top are never highlighted. In the left side face, it's highlighting the side on the left. The front face, again, is the front. Right side face is the side on the right, and back face is the one on the back. But never do you see highlighted the one that's flat on the ground or the one that's facing like the ceiling. So again, the top and the bottom not included. That's what lateral area would be. So you'd find the area of, in this picture specifically, all of the pink shaded faces and add all 4 of those areas together. That would get you lateral area. If you needed the overall surface area, you would then include the top and the bottom as well and add all 6 of those together. Okay, one other little thing you need to know before we start getting into the math of it all is this right here, right versus oblique solids. So a right solid is when it's standing up straight. So I use the triangular prism to represent this, but any shape can be right and oblique. So for this triangular prism, a right would be when it's standing up completely straight. Oblique is like it's tilted a little bit to the side. That's really all you need to know about what an oblique solid is. The rest of it's going to come from formulas. So just have that idea. A right is standing up straight and oblique is just kind of tilted over to the side. All right, all of the formulas you're going to need to know, and you're not going to use all of these, but it's definitely huge for you to know. So that's as big as I can make it. I highly, highly, highly recommend you screenshot this page right here because no one wants to write all of these out. Just screenshot this and you can refer back to these formulas while we're working through all of the problems that require them. So for example, if a problem says to find the volume of a cylinder, you would go to that bottom table, find volume, match it up with cylinder, and see that the formula for the volume of a cylinder is V equals pi r squared h. Now, there is a lot of letters in this. You'll notice through the whole volume column, it's V equals. Surface area is SA equals. That's all that stands for. And lateral area is LA equals. I just don't want you to get those L's and S's confused with what they stand for within the formula. So SA is surface area, LA is lateral area. And then within the actual formulas, you'll see these letters written at the bottom of this page. So L stands for length, W is width, H is height. That's pretty self-explanatory and stuff you already probably know. B is base, which you're really not going to work with much at all. R is radius, and S is something called slant height. So I'm going to bring you back up to this picture of the oblique. When it's tilted on its side, it's no longer a vertical height. When you're talking about height, especially when you're trying to find volume, surface area, or lateral area, using these formulas, height has to be perfectly perpendicular to the bottom or to the base. So it needs to be perfectly straight up and down. A slant height is exactly what it sounds. It's literally just slanted. Okay, so a slant height would be slanted. A perfectly vertical height, if I could draw a perfectly straight line, would be like this. This is a height. This over here is a slant height. Okay, one last thing that you need to know, but we're going to dig into it when we do some examples, is that thing on the very bottom of this formula page. It says in terms of pi. Apex is really in terms of pi friendly. If you have to use any of the formulas on this page that has a pi in it, oftentimes on your Apex quizzes, it'll tell you to leave your answer in terms of pi. So let's go back to that cylinder volume formula, V equals pi r squared h. If you were directed to leave that in terms of pi, it means you would not plug pi into your calculator. You would only plug in r squared h, and then pi would just be written in the multiple choice answer. So again, I will do some examples like that with you, and you'll see that in just a minute. Okay, so we're going to start with volume. So let's say you're doing your Apex quiz right now. Sorry. And you have to find the volume of this shape. This is a rectangular prism. So what you would do, even though I already have it written, what you would do is go to your formula page in the volume column, because we're trying to find volume, match it up with rectangular prism, and you see that the volume formula for a rectangular prism is length times width times height. So I already have it written because I don't plan on scrolling up for every single one of these. But that's how you would find the formula based on the shape that you're given. Now, length, width, and height really don't matter too much when you're dealing with these. Like if you look at the shape, there's three numbers. One of them's your length, one of them's your width, and one of them is your height. They can alternate depending on which angle you're taking the view of the shape on. So like if I'm considering this to be, whoops, sorry, that happens all the time. If I'm considering this to be my length and this to be my width, that means this is my height. If this is my width and this is my length, that means this is my height. But ultimately, because of the commutative property, it does not matter what order I multiply them all together in. So I'm just going to say my length and width is what I said originally. Length is 3, width is 5, which means my height is 12. So this is one of the easiest ones to plug into your calculator. You would just do 3 times 5 times 12, and that gets you 180. Now, This is volume, so it's three-dimensional. What that just gave me is 180 measures the entire space on the inside. Like if I were to fill this rectangular prism, let's consider it a cereal box, with cereal, it would be filled with 180 inches cubed. And that's it for a rectangular prism. All right, number 2 is a triangular prism. I definitely wanted to do this one with you because the formula is a little confusing. So ultimately, if you remember from the last video, we talked about piling. All prisms are one two-dimensional shape piled on top of each other to reach a certain height. You'll notice for the rectangular prism, it's a little bit trickier because it could have been this that's not helpful. It could have been this rectangle piled until it got to this one. It could have been this rectangle piled on until it got to this one. But for a triangular prism, I know this is really, really hard to see. Just looking at this video, I'm doing my very best to show you two-dimensionally what this looks like three-dimensionally. Okay, for a triangular prism, this has to be your base. And that triangle is piled and piled and piled all over and over and over again until you get to this. So you got your base and your top right there. I'm gonna get rid of that because it made it ugly, but hopefully that helps you see your base and your top. Now with that concept of piling, that means that we took this over and over and over again. So to find the volume, what you have to do is just find the area of your base and multiply it by the amount of times it was piled, which in this case would be times 18. So when I go to plug this in, it's V equals, and again, I got this formula from that formula sheet. I'm gonna leave parentheses everywhere I see them. So 1/2, this is times my base. So the base is of this shape right here, the triangle. So the base is 9 times the height of the triangle, which notice it's perpendicular to the base of the shape. So that's going to be a height of 4. And then that other h, so this is why it's confusing. There's two h's. This one is the height of the triangle because this is the overall formula of that base shape, which is a triangle, times the overall height of the whole thing, which is this right here. That's going to be 18. Okay, so take a second to practice plugging this in your calculator too. Use the parentheses where you need them. You can do 0.5 instead of 1/2 if you don't want to plug in a fraction. And you should get 324. Now this is volume again, so it has to be something cubed, but there's no units given here. It was just numbers. If there's no units given, it's going to be just units cubed. All right, I believe we have one more volume example, and then we're going to get, and then we're going to get into surface area. All right, so here's an example of in terms of pi. So if this was a question on my Apex quiz and I knew I had to find the volume, I would notice that this is a cone. Again, just going back to that picture, I would then find where volume and cone match up, and it's 1/3 pi r squared h. So 1/3 pi r squared h is already written there for me, but I have to leave this in terms of pi. So just a refresher, what that means is you're not going to plug the pi into your calculator. So I'll explain that further once we get there. So plugging all of the things we need into this formula, the 1/3 and the pi don't get plugged in. They just are what they are. R stands for radius. Remember, radius is half of the distance going through the center across a circle. So, the center of the circle is here, and half of the length to the outside of the circle would be 4. So the radius is 4. I'm going to do 4 squared times the height. Now keep an eye on the height. It's a really important concept. See how it's going from the top perfectly straight to the center of the circle. That makes it a perfect height. It's not a slant height. This over here that I'm doing in green, that is a slant height, which we'll talk about a little bit later. Okay, so I plug in that height of 26. And then we're good to go. Now remember, when you're plugging this in, you're not plugging in the pi. So it's almost like the pi is not there, but it does come down in your answer. Okay, so this is what you're plugging in, no pi. So 1/3 times 4 squared, or times 16 if you want, and then times 26. hopefully you got, and I'm just going to write this really quick, 138 point, and it's a lot of sixes. So just 6 repeating essentially. This will happen a couple of times throughout your quizzes on Apex, but they will just round them to the nearest whole number for you. So this 6 bumps that 8 up to a 9, so it's going to be 139, and then remember that pi comes down. That's what in terms of pi means. Your overall answer is going to be 139 pi. Now again, this is volume, so my units are going to be centimeters from the problem cubed. Final answer. I'm pretty sure there were no questions that didn't say in terms of pi. If it doesn't say in terms of pi, you would just still multiply that pi in. If you do this whole thing times pi, you would get 436 centimeters cubed. Again, it's just plugging it all in. All right, now you definitely have way more examples throughout your Apex quizzes than I am doing with you. I'm trying to pick the ones that are the most out of the ordinary. So like this one, again, it had 2 heights, so I definitely wanted to do one like that with you. A cone, for sure, I wanted to do with you because it was left in terms of pi. You're going to see some where for volume with spheres. It's the same idea. You just go here. Sphere would be 4/3 pi r cubed, so you just plug in the radius and then plug it straight into your calculator the same way that we plugged in number 3, but you would use 4/3 instead of 1/3, and so on. So really, it's just knowing which formula to use and then how to plug it in your calculator. So I'm not going through every single shape with you because you'd be here all day. I'm just giving you the gist of what you need. If you need more, absolutely reach out and text me. Okay, so that's about it for finding the volume, so like the space inside of a 3-dimensional object. Now we're going to do surface and lateral area, which again is finding the overall area, combined total area, of all of the outside shapes. Lateral excludes the base and the top. Okay, so lateral area formulas are actually a little bit easier than surface area, and I did not see anywhere on Apex where you had to actually apply a lateral area formula, at least not more than like one question maybe. So I'm not going to do any lateral area questions with you because like I said before, it's just applying the formula. If you look, let's do the lateral area of a cone. Look at that formula real quick. Pi RH. You just multiply R and H together, bring your pi down, and you're done. So because those formulas are a little bit easier, I'm not going to bother doing too many of them with you. Surface area is a lot tougher. You can clearly see that by how much more challenging their examples are because they include the top and the base, so they are definitely harder. So we're going to start with the surface area of this shape right here. It is a square pyramid. So I see it's a square pyramid. It's a pyramid because it comes to a tip, and the base is a square. That's what makes it a square pyramid. And you would find the formula for square pyramid in your formula page. Okay, so now my surface area formula is length squared plus 2LS. So L stands for length, S stands for slant height. I wish I could like tilt this picture around and show it to you a little bit better. Length is definitely going to be, 16, because it's the length of the square. Your slant height, try to picture this as a pyramid. I'm gonna just draw like the front of it for you. This is, oh, no. That went better in my head. We're not going to draw the slant height for you because I just cannot draw this for you. I'm doing the best I can. I'm sorry. If you look at the picture, you can see... I'm going to try. Just bear with me for a second. We're going to give this a solid effort. Ooh, that's pretty. Okay. So slant height is different from height. Regular height would be if you went from the tip of the pyramid perfectly down to the center. I can't draw it on this actual shape. It won't let me. I'm sorry. This is the best I can do for you. So from the very tip of the pyramid to the center of the base would be a perfectly perpendicular height from the top to the very bottom. This one is drawn from the tip to the side. You can even see my green line is slanted. It is a slant height. So this problem gives you slant height, and the slant height is 19. So now it's just a matter of plugging in. So SA, remember, stands for surface area, which is what this problem's trying to make us find. L is your length, so length is 16. I'm going to do 16 squared. You should get in the habit of putting anything you're squaring in parentheses. That's why I have been. It won't be wrong if you don't for these types of problems. I bring down the +2 and then plug in length again, so times 16, and then times that slant height, so times 19. So take a second to practice plugging that in. I'm sure you noticed I've had the answers in the bottom corner. I'm plugging them in with you just to make sure I'm getting the answers right. Sometimes we plug in the problem wrong. Believe it or not, a couple problems ago, instead of plugging in 1/3, I accidentally plugged in 11/3. I just hit the 1 twice. It happens and we make mistakes. So that's why I want to just make sure I'm getting the answers right and not just going on a whim if I accidentally plug something in wrong. Okay, so once you plug that all in, the surface area is equal to 864. So 16 squared plus 2 times 16 times 19, 864. Now, this is an area problem. Even though it's three-dimensional, we're finding area, not the space on the inside of the pyramid, the space taken up by its faces. And there are 5 faces for this problem. Okay, so it doesn't tell me what the units are, but because it's area, I know it's going to be units, and it has to be squared, again, because it's area. So this is my total final answer. Now, these surface area formulas were created by some very, very smart mathematicians to help you easily find the surface area. Surface area's idea is to take the area of all of the shapes on the outside and add them together. So I'm going to go over that with you very, very quickly because you're probably just going to use the formula. But remember, there's 5 faces to this shape. So the area of those 4 identical triangles plus the area of the base, which is a square. So this is where the area formulas on this come in handy. The area formula for a triangle is 1/2 base times height, and for a square is just length times width. So going back to that problem, I lost my spot, there we go. Those 4 triangles is going to be 4 times the area formula, which was 1/2 times the base, so times 16, times the height, which is 19, plus the area of the base, so length times width was just 16 times 16. Okay, so this is that whole idea. It's 4 of these triangles, and the area of the triangle is 1/2 base times height, and the area of that base, which is a square, is 16 times 16. So when you go to plug this in your calculator, which you can if you want to, you don't have to. Again, this is like another way of doing it. You don't have to do both of these things. I'm just showing you the idea of surface area. Look at where this formula came from. This was length times length. It was already done right here. Those 4 triangles, 4 times 1/2 is 2. And then 16 times 19 is right there. So this is like the longer way of doing it to like actually put your brain to use rather than just grabbing the formula, plugging in, and getting your answer. But this is like the idea. So all of the sides, all 4 triangles and that base added together to get you 864, that total surface area. All right, next one we're going to do is the surface area of a cone, and we're going to find it in terms of pi. So in terms of pi, remember, means you're not going to plug pi into your calculator. So the surface area formula for a cone is given right here, and we need to plug everything in. This one is much more difficult than the previous ones have been. I'm actually going to scoot this over just a teeny bit. Give myself some space. Okay. So we need the radius, we need the height. Those are the only 2 letters throughout this problem. We're going to use the radius 3 different times. So when I go to plug in my numbers, I bring down the pi. For now, I'll get rid of it before I plug it in the calculator, times the radius, which is 3, then my parentheses come down. If parentheses are given in a formula, it's crucial you bring them down. Okay, r, again, is 3 plus the square root of. And here's where we're going to have a big, big problem. Height. For a cone, I can draw a cone real easy. Whew. Okay, right now we have that this is 3 and this is 12. This side right here is your slant height, which is S. We don't need slant height. What we need is height. This perpendicular to the base height. That's not given. And you have a couple on Apex that aren't going to be given either. So this needs to be found. And we're going to backtrack to something we have done way back when you have a right triangle and you have a missing side length. I'm going to pause and give you like 10 seconds to try and think of what you might need to use to find that missing side length. Hopefully you're thinking Pythagorean Theorem. Okay, Pythagorean Theorem is a squared plus b squared equals c squared. That is the formula used to help you find the missing side of a triangle. So we're trying to find this side. When you're using the Pythagorean Theorem, this number, your hypotenuse, always across from the right angle, is going to get plugged in for c. So this is going to be 12 squared, and then these ones don't matter. So I'm going to leave a squared and plug in 3 for b. If you do 3 for a, it won't make a difference. So a squared stays, plus 3 squared, which is 9, equals 12 squared, which is 144. Now your goal here is to find a. This is a. So your missing side is a. That's what I'm trying to find. So the first thing I'm going to do to get a by itself is subtract the 9 from it. So subtract 9. Let me get this out of my way. Okay, when you subtract 9, I get a squared is equal to 135. And then a is still not by itself. It has that squared there. So to undo a squared, you take the square root. And the square root of 135, I do not know. So I plug it in my calculator, and I get 11.61895, and so on. So Apex is mean. They did not give you a nice number here because, you know, they're not nice. So that is your vertical height. That is this in the picture, the height that was not given. So it's crucial that you know the difference between slant height and regular height because they might try and trick you like this. Plugging in 12 for your height will not work. I bet they will give you that answer on there. So please be cautious. So now I'm going to go back to my formula. Remember, the next thing we needed to plug in right here was the height. Now that I know it, it's 11 point, I'm just going to do 61895. Square that, plus r squared is going to be 3 squared. Okay, this is probably the toughest one you're going to have to plug in. Definitely why I'm doing this one with you for an example. So remember, we have to leave this one in terms of pi. So you're not going to plug in pi. You're just going to leave it in that last step for your answer. This right here is what you are going to plug into your calculator. Parentheses everywhere you see it. So take your time, 3 parentheses. 3 plus the square root. If you don't know how to get a square root, you hit second and then you press the x squared button. Okay, keep going. Parentheses 11.61895. Close your parentheses squared plus 3 squared. Your decimal might not be as long as mine. I'm not quite sure where your calculator rounds. I'm just using an app on my phone, the best thing I could find for now, because I left my calculator at my desk, which was not very smart. But to round this to the nearest whole number, which is what Apex does throughout all of your quizzes for these kinds of questions, that 9's going to bump that 44 up to a 45, and remember that pi comes down. So the surface area for this example was 45. Remember, it's still area, even though it's three-dimensional. It's going to be some kind of units squared, and this problem doesn't give it either, so it's going to be just units squared. Okay, and that is all the examples I have for you. Remember, if you're asked to find lateral area, you'll do these same kinds of problems. You're just going to use the lateral area formulas. If it asks you to find certain volumes or surface area, just use those formulas. Even if I didn't do an example of it, it's still going to be the same idea, same concept. Find the right formula, plug in the right information. Remember the difference between height and slant height. This is slant height, this is regular height. Make sure you have the right thing given to you. And remember to leave it in terms of pi and not plug in pi when it asks you to. If you did plug in pi for this example, it would have been 141, and they might have that as an answer for you, 141 units squared. So just be cautious that you don't plug it in when they instruct you to not plug it in. I would hate for you to get the wrong answer when you did all of this right. Okay. So just like usual, if you have any questions, please feel free to just text me. I can make you another video if that wasn't enough. I can make a sphere example. I can do anything you need if you're having a hard time, but you are good for the rest of Unit 14. Just make sure you definitely got a screenshot of this page. You saw how much we used it. It's going to be used that much throughout your quizzes as well.